Welcome to Ask and Learn.
We are asked to construct a deterministic finite-state automaton that recognizes the set of all bit strings that do not contain 3 consecutive zeros. So, the set of strings we're interested in, if it doesn't contain 3 consecutive zeros, let S be the set of all bit strings not containing 3 consecutive zeros. And let's pick a start state S0. And let's consider 4 different states, S0, S1, S2, and S3. So S1 will represent that the last digit was 0. And on top of that, there was no 0, 0 preceding the last digit. S2 will represent the last 2 digits were 0, 0. But there was no 0 preceding it. The bit preceding it wasn't 0. And finally, S3 will represent that the string contained 0, 0, 0. S3 represents string contains 0, 0, 0. And now, to describe the transitions, we're going to, of course, start at S0, since we designated this will be our start. And we have that S0, S1, and S2 will all be final states, since all of the strings containing 3 consecutive zeros end at state S3. Okay, so suppose that the string contains a 0. Then we're going to move from S0 to S1. And then suppose the string contains a second 0. Well, first, otherwise, the string contains no zeros, then we're going to remain at S0. So now suppose that the string has second 0 as the next bit, and we're going to move from state S1 to state S2. Otherwise, so if the next bit is not 0, or if it doesn't have a next bit, we're going to remain at, or we're going to move back from S1 to S0. This is because the last digit must be a 1. Now, suppose that there is a third 0 in the string. Then we're going to move from S2 to S3. And we see that once we're in S3, we'll remain there, no matter what input we get. But otherwise, so the string does not have a third 0 as the next bit, so the string has a 1 as the next bit, then we're going to move from S2 back to S0.